chemical reactions, balancing equations, and acids and bases, endothermic and exothermic, and physical and chemical changes. Number 1, which subatomic particle do atoms gain, lose, or share when they form chemical bonds? So this is a picture of water, H2O. How are they bonding? Through their protons, their neutrons, their inner or outer valence electrons? They are bonding through their valence electrons. That is how atoms form bonds. They don't connect with protons and neutrons because those are in the middle. They connect or form bonds using their valence electrons. Question 2. Count the atoms in one molecule of H2SO4. So this is really easy. All you have to do is just see the subscripts. H2 means there's 2 hydrogens. S, if there's nothing after the S, that means there's like an invisible 1 there. Okay? So how many sulfurs do you have? You have only 1. And then oxygen, you see a subscript of 4, so that means there are 4 oxygens. Alright, count the atoms in 2C6H12O6. So if you remember from last year, this is glucose. So if I have 2 coefficient over there, what you have to do is distribute or multiply. You take this big 2, multiply it by all of these subscripts. Okay? If this were an equation problem and I had like a plus sign here, that's where I would stop distributing. Okay, but I'm just counting this one. So carbons, 2 times 6 is 12. So that means there are 12 carbons. Okay. Each hydrogen, I'm going to do 2 times 12. That's 24 atoms of hydrogens. And then oxygen, I have 2 times 6. That's going to be 12. So on your test, you need to know how to count these atoms. 4. How many oxygen atoms are there in one molecule of LiSO4? So this one's only asking me about oxygen. Oh, I see a 4 here, but I also see a subscript of 2 here outside the parentheses. Whenever I see this, I need to distribute this 2 to everything on the inside. I stop. I do not distribute to the Li because that's outside the parentheses. So I'm only doing O, so I have to do O4 times 2. That's going to give me a total of 8 oxygens. Okay? If I was doing sulfur, it will be 1 sulfur times 2, and sulfur will only be 1. If I was counting lithium, it will only be 1 because I'm not distributing that 2 because it's outside the parentheses. You need to know the difference between a physical and a chemical change. A chemical change is when you're forming something new and it's hard to reverse or go back to the original form. Physical change, you can easily go back to the original, or nothing new is formed. So if I break a stick, it's still a stick. It's just a stick broken in half. I did not change the atoms in that stick. So it's a physical change. Burning a match. Anytime you hear fire this, like burning, it's chemical. Because when you burn something, you add energy to it and you change the atoms. Okay? And you cannot unburn a match. So it's chemical. Metal rusting. When metal comes into contact with air, it gets like dirty and old looking. That's called rust. Alright? That is a color change, right? Because it goes from being all shiny to being all like nasty looking. So that is a chemical change. Okay? Rust is a chemical change. Tarnishing metal. When you tarnish something, that means it loses luster or becomes less shiny. So if something becomes less shiny, it's kind of similar to this one with the rusting one. This one becomes less shiny as well when metal rusts. So when you tarnish a metal, it becomes less shiny. That is a chemical change. Right? Melting ice. If I have a block of ice, right, this is H2O. It's just water molecules that are really close together. When it melts and forms water, you guys know this, it's still H2O, right? So I'm not changing the atoms, it's still H2O. So this is a physical change. Baking a cake, when I mix all the ingredients in the oven together and I put it in the oven and I get a cake out, I cannot unbake a cake, right? Something new is made. This is chemical. Roasting a marshmallow, again, another example with fire, okay? So this is chemical, all right? We did that one with Marshmallow Man. Mixing lemonade and water, all right? If I have a glass of lemonade and I put, water, and I put lemonade in there, okay? The water is still water, and the lemonade mixes with the water, but it's a physical mixture, okay? This is a physical mixture that you can separate, all right? I'm not making anything new, so this is an example of a physical change. Cutting hair, it's still hair, it's just shorter, it's physical. If I was bleaching my hair or dyeing it, that would be chemical. If something gets bigger or smaller, it goes from a triangle to a circle, or it changes state of matter. Remember this 3 states of matter, or solids, liquids, and gases. Those kind of changes are physical changes. Okay? Water evaporating, so this water, when it evaporates and it turns into a gas, that's still H2O. Okay? So that's going to be a physical change. So this one, it goes from a liquid to a gas. That is a state of matter change, and we know that is a physical change. Okay, precipitate, that's a fancy new word you guys learned. That means new solid, and you guys should know that is one of the 4 signs of a chemical change is occurring. Okay, what is the name of a chemical reaction that when a base mixes with an acid? Okay, so when you have an acid and a base, it's a specific type of reaction. Okay. We did not study this one yet. I've never told you guys anything about this. I've never told you guys anything about that. So you're left with these 2, and we know from the pH lab that these kind of reactions are called neutralization. All right? When you have an acid and a base, and it makes salt and water, that is called a neutralization reaction, or an acid-base reaction. Okay? Define combustion and name a substance that is combustible. I kind of put a cute little picture here to help you guys out. So if something is combustible, that means it's a chemical property, right? So let's just write here, chemical property. That means if a substance will, look at the picture, catch fire or ignite, catch fire in the air. Okay? Your favorite combustible substance is what you get all the time and you put it inside your car. Good old gasoline. Gasoline is combustible. Perfect. Okay? Alright, you need to learn how to read this. Okay, we did this in the experiment when you guys put like a coil of magnesium ribbon inside of that that blue liquid stuff. Okay, we did this lab. So blue copper sulfate, CuSO4, combines and reacts with magnesium ribbon and yields magnesium sulfate and copper precipitate. This is represented by the chemical equation below. Use the bold underlined words from question 8 to answers A through D. So all of these words need to go somewhere over here. List the reactants in the chemical equation. I know my reactants are going to be everything over here. These are my reactants. So my reactants are CuSO4 and Mg. Okay, and those are the underlined from question 8. We're just taking whatever is underlined and putting it over here. List the products in the above chemical reaction. My products are always on the right side of the chemical equation. Products means what comes after. Okay? Reactants, fancy schmancy word for ingredients. What are you mixing together before? Okay, so list the products. I have two: MgSO4, magnesium sulfate, you don't have to know what that is, and copper came out. All right, what does the plus sign mean? This plus sign right here. That plus sign means combines and reacts with. Combines and reacts with. You're mixing it together. Reacts with means it does something to change. Okay. What does the arrow mean in the chemical equation? Yields. Okay, yields. Yields is a fancy word for makes. So this plus this reacts with this to make or yield these two. Okay. Is this equation balanced? Let's see. On the reactant side and the product side, I have to count the atoms. For Cu, copper, I have 1 copper on the reactant side, 1 copper on the product side. For S, I have 1 and I have 1 on both sides. For O, I have 4 and O, I have 4. Okay, this is how you're going to have to be doing this on your test, telling me if something is balanced. For Mg, I have 1, and Mg, I have 1. So, is the above equation balanced? Yes, because I have the same number of reactants as I do in my products, so I don't have to balance it. I'm good. Number 9, it says list the reactants and list the products and give me 2 clues that a chemical change occurred. I combined steel wool and copper sulfate in a baggie and a color and temperature change occurred. Copper and iron sulfate are formed. So my reactants, my ingredients were what I combined: steel wool and copper sulfate. Okay, we did this lab. This is when you guys took that piece of like silver gray metal and you put it in the baggie with the blue stuff, the blue solution. List the products. It says copper and iron sulfate were formed. So I'm going to write that here. Copper and iron sulfate. And which 2 clues let me know that a chemical change occurred? Right here. Color and temperature change. Perfect. Okay, this next one. The mass of the reactants will be what compared to the mass of the products in any chemical reaction because of which law? Alright, so if I'm looking at my answers, my mass of the reactants needs to be what in compared to the mass of my products? If you remembered, they should be the same, okay, or equal. So I can't do this one because that's double. It's not double. It's not half. It's always the same or it's always equal. So which one was it? The law of conservation of energy or the law of conservation of matter and mass? This one. Okay. We're going to talk about this law of energy in the next lab book. Alright, but D is letter 10. Whatever you start with is whatever you end with. Okay. Question 11. Which number should go in the blank to balance this chemical equation? Alright, I left you some space over here. So let's see. Let's do the reactants. Let's do the products. I have H and O. H and O. So I have to count those. Alright, and this side, on my reactant side, I have 2 of each. Okay. On this side, I have 2 times 2 is 4 hydrogens, right? 2 times 1 is 2 oxygens, but I have to add these 2. So I have to put 4 here. So obviously, they're not balanced. If they're not balanced, I have to put something here to balance it. So let's see. If I'm trying to figure this out and I see, my reactant side, there are 2. In my product side, I have to make they became 4. So what can I put here to make these 2, what can I multiply here to make these 2 to go into 4? If you think, If I put a 2 here, this will be 2 times 2, which will make it 4 hydrogens, and then 2 times 2 oxygens, which will make us 4 oxygens. Now, it's beautiful and it's balanced. Alright, so what number should go in there? 2. A coefficient of 2. 12. According to the law of conservation of mass, what is the mass of copper in the above chemical reaction? Alright, so CuSO4 is 53 grams, Mg 27 grams, MgSO4 is 62 grams. What is the mass of this copper? So remember the law of conservation of matter. What I start with is what I end with. So let me add my reactants mass. Okay, my reactants mass is 53 grams plus 27 grams. That's going to be 10, 5, 6, 7, 8, 80 grams. So this, my reactant side, has a total mass of 80 grams. That means this whole thing needs to also equal 80 grams. If I know one of my products is 62 grams, that means, boom, I have to subtract 80 grams minus 62 grams. Excuse me, and that's going to give you a total of 18 grams left. Alright, 18 grams. That way both sides are going to be equal to 80 grams. 13. An unknown substance turns pH litmus paper blue, tastes bitter, is corrosive and slippery. So, if it turns your pH paper blue, you saw this last year in 7th grade science. If it's green, that means it's 7, that's neutral. If it turned yellow, orange, and even worse, red in your fish tanks, this is acidic. So if it turns blue and purple, you're looking at your bases. So 9 is an example of a base. Alright? So use your notes on acids and bases for this one. If it turns pH paper blue, it tastes bitter, it's corrosive, and is slippery, you're looking at a base. Alright? Acids taste sour, okay, and they turn pH paper red, okay, or orange. Alright, exo versus endo. Okay, remember exo means outside, so when you're outside it's releasing energy. Endo means inside, so you are absorbing energy or you're taking it in. If you're releasing energy, your temperature is increasing. Alright? If you're absorbing energy, that means you're sucking it in from your surroundings. That means your temperature is decreasing. So a chemical hot pack becomes warm, it releases energy, and it increases the temperature. This is your exothermic reaction. And when it becomes cooler, absorbs energy, and decreases temperature, this is your endothermic reaction. This is also going to be on your test. Make sure you know the difference between both of those reactions. Okay, 15 is similar to the one we just did. The reactants in the chemical equation have a total mass of 150 grams and yield a solid and a gas. So I'm starting with 150 grams. And it makes a solid, and it makes a gas. Okay? It always helps to sort of write it out and explain your thinking with your words, with your writing. The gas has a mass of 100 grams. What is the mass of a solid? So it's asking you, what is the mass of this product? If you start with 150, you end with 150 grams. Perfect, you got it. So 100 grams here, so this obviously has to be 50 grams. Perfect. Almost done. The chemical formulas for acids begin with H because they have a high concentration of hydrogen ions. So they have a lot of hydrogen ions. Bases end in OH because they contain a lot of hydroxide ions. Okay? This should be ringing a bell. Circle the two chemical reactions below that represent an acid-base or neutralization reaction. Remember from question number 6, what is the name of a reaction when a base reacts with an acid? That's neutralization. We said it was an acid plus a base makes a salt and water. So you're looking for two formulas between these two that have an acid and a base, and they make salt, and they make water, which is H2O. So, how do you know if it's an acid? It starts with H. How do you know if it's a base? It ends in OH. So let's look at this one. NaOH, HCl, H2O, and NaCl, which is table salt. I know this is a base because it ends in OH. I know this is an acid. I know this is water. So this must be my salt, right? So this is one of those reactions, okay? Look at this one. I only have one reactant. I don't have an acid and a base. So if I only have one reactant, this cannot be an acid-base reaction because I need two reactants. I need an acid and I need a base. Okay, CH4, that doesn't start with an H, doesn't end with an OH. O2, that doesn't start with an H or end with an OH, so that's not an acid or a base. Okay, I have a water here, but is this a salt? No. Okay, salts, and this is TMI, too much information, starts with metals. Okay, so NaCl, Na is a metal. Okay, and that's kind of too much information, but that's usually how I can tell. Let's look at this one. KOH. This is a base because it ends in OH. HCl. This is an acid. And it makes water. Perfect. And, well, first of all, I have an acid and a base. So I know it's an acid-base reaction. Okay? And then this is my salt. And K is potassium. That is a metal. So A and D are your acid-base reactions. Okay? And look over here. This is a neutralization reaction right here. Okay, you have an acid and a base, and you mix them together, you get salt and water. What are the 4 clues to a chemical change? You guys should know this by the back of your hands. Temperature change, color change. A lot of you guys like to say odor or gas. What you want to say for this one is gas bubbles. Okay, you see fizzing, you see, you can smell something, but we're really looking for the presence of bubbles, okay, or some kind of fizzing. And the last one, a new solid is formed, or a new substance is formed, and we call that the precipitate. Okay. It says number the pH scale below. A pH scale goes from 0, 7 to 14. So there should be like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Then label where you would find an acid, base, or neutral. So acids are over here. Your neutral is 7. And your bases are over here. If something has a pH of like 6.5, it's an acid. Okay, we really want to say neutral is like 7, 6.99, 7.01. Okay, for anything outside 7, you just want to stick with acids 1 through 6, bases 8 through 12, or 8 through 14. Okay, what chemical bond is formed when calcium, a metal, loses its valence electrons to chlorine, a nonmetal? So if I have a metal and a nonmetal, that should ring a bell. That's an ionic bond. Okay? And remember, metals you find to the left of the periodic table. Okay? I'm going to write it here on the bottom. Nonmetals you find on the right of PT, periodic table. On your test, I'm not going to be nice and say, hydrogen is a nonmetal and fluorine is a nonmetal. What kind of bond is it? No, you're going to have to look at the periodic table and say, hydrogen is a nonmetal, fluorine is a nonmetal. When I have only nonmetals, that is a covalent bond. All right?